Okay, so number 13 is a little bit unfair because they were expecting you to throw together two concepts. One you learned yesterday, and the other one is way back in the middle of Calc 2. So for number 13, they want you to draw some contour lines and try to visualize f of x as the cosine of the square root of x squared plus y squared. Okay? So you can go ahead and try to do this. It's gonna be a little funky. Let's try one just for kicks. So like the zero level curve, say, right? Like start someplace. I would start with the zero level curve. Okay, so if we start with z as 0, I'm looking for when is 0 equal to the cosine of the square root of x squared plus y squared.
When x and y equal 0.
Well, actually,
No.
when x squared plus y squared equals root 2.
Equals pi over 2.
Or yeah, pi over 2.
Oh.
Pi over 2.
Or a multiple.
Okay, hang on, wait, you're all talking too much and I don't remember enough trig. Cosine looks like this one, right?
Yeah.
Right, it's the one that starts at the top. Good. And this happens at
Pi over 2.
pi over 2, and this is at 3 pi over 2.
Oh.
Okay, so it's the odd pi over 2's, right? Okay, right? Crap, right?
Yeah.
Okay, so the thing, do you want to know the thing they were expecting you to put together?
Yeah, that'd be pretty cool.
Okay. Take problem 13, convert to polar. Why would you convert to polar? What was my cue to convert to polar? Yeah.
Circle-ish looking.
Yeah, there's a circle-looking thing in there, right? What's the circle-looking thing? Yeah, this part. You guys all see that? So I'm going to convert this to polar, and now I'm going to talk about the function f of r and theta, right? What's f of r and theta?
That's let's see, it's
X
oh
of
my gosh,
r
it's just r
over
cosine of theta. Or no wait.
Cosine.
I,
This is easier.
Oh, yeah.
This is just cosine of the radius.
okay.
You guys all see that?
Because that's what a circle is.
So anytime I'm wondering about when is the square root of x squared plus y squared equal to an odd pi over 2, all I'm wondering is when is the radius an odd pi over 2. You guys see that? And so now I get this like picture, easy peasy, no problems. So the radius is an odd pi over 2 when the radius is pi over 2. It's also an odd pi over 2 when it's 3 pi over 2. And when it's 5 pi over 2, right? Okay, so this is a z at 0 level curve. That's a z at 0 level curve. That's a z at 0 level curve, right? You guys see this? It's ripples. And then what's it do in between the ripples?
Maybe up and down depending on which we're in.
Yeah, so it starts up at the top, right?
And then it goes
And then
down.
it drops in, and then it hooks under the board, right?
Yeah.
And then it ripples up. This literally is just ripples. This is what would happen if you dropped a rock in a frictionless pond. Because the ripples aren't getting smaller, right? You guys all see that?
Mhm.
If I wanted the ripples to get smaller, just for kicks, right? Because we're, like, I think you guys can do the rest of this problem from here. What is the rest of the problem?
It's the same as.
Oh yeah, throw some contour lines in here. So toss some more contour lines in here. It's not hard.
Z equals 1 is halfway in between each. So
Yeah, so the z is 1 contour line starts here at the middle,
And it's at every.
And then, let's see, so these are up, and then these are down, and then in here we're up. So this middle circle in here is a Z is 1 contour. And then you skip a ripple, and then it's the top of the next one, right? It's the peaks here. And then, what other one's easy to label?
-1.
Yeah, the Z is -1 is easy to label. That one's right here. And then pick your favorite other thing between -1 and 1. Cool? If you wanted to make the ripples die, how would you do it? So, in other words, what would be a good model? Like, this is a crappy model for throwing a rock in the pond, right? So, what's a better model for throwing a rock in the pond? F of r and theta is,
Divided by something.
Cosine r divided by r squared.
okay.
You guys freaking-
That would work.
Yeah, yeah.
So that would be an inverse square rippling. That's probably not how friction works.
Well, I'm not thinking of friction.
That would be like
If-
gravity
but That would
ripples.
be frictionless, that would be frictionless dropping it in, because in a frictionless pond, as you get further away from the center, the ripples will actually die down because they're getting more spread out. Works just like gravity.
Oh, it probably does.
Because that same amount of
That's a fair
energy
complaint.
is spread over a larger circle.
Yeah, good
So
point.
cosine r divided by r squared would be like a frictionless pond.
Sure, yeah, that would divide the energy out by an area rule, which is about right. You guys all see that? What would dividing by r cubed be like?
Yes.
That would be like dividing by a volume kind of thing, right? That's probably too much. You guys see that? If you wanted to just make the ripples get smaller by maybe exponential decay, how would you do that?
Divide by e to the.
Yeah, you throw like an e to the minus kr in here, and then do a cosine. You guys cool with that? Keep in mind, right? When the math's easy, the physics probably is broken. And when the physics is right, the math is really, really nasty. Cool? Questions, Steels? That help? Right?
Yeah.